Good morning, students. In today's class we are going to see the fourth experiment, that is design and realize a Schmitt trigger circuit using an op-amp for the desired upper trip point and lower trip point. First we will see what is meant by a Schmitt trigger. Schmitt trigger is nothing but it is a regenerative comparator circuit. So the Schmitt trigger circuit is designed with a positive feedback and hence it is called as a regeneration action will takes place, which makes your output to switch the levels between your upper trip point and lower trip point. Also, we can use the positive feedback instead of negative feedback, which aids the feedback voltage to the input voltage instead of opposing it. So here the output output voltage will be aiming, that is increasing instead of decreasing. The use of your regenerative circuit, that is the use of Schmitt trigger circuit as a regenerative circuit, is to remove the difficulties which we have faced in a zero crossing detector due to the low frequency signals and input noise voltages. Now we'll see the experimental circuit diagram that represents the Schmitt trigger circuit by using an op-amp, and we can measure the upper trip point and lower trip point. The main aim of the experiment, we need to design the Schmitt trigger circuit by using an op-amp IC741 for different hysteresis value, and from there we need to obtain the upper trip point and lower trip point. The Schmitt trigger is implemented for hysteresis of 1 volt over here. The circuit diagram for the Schmitt trigger is shown over here. You can see the input is given at the inverting terminal and the feedback is given at the pin number 3. Pin number 3 is nothing but it is a non-inverting terminal where we can say positive feedback is given over here. So this R1 and R2 will act as a voltage divider bias, and it is the reference voltage we are given over here. Now the design of Schmitt trigger, now we can consider the upper trip point is to be 3 volt, lower trip point as minus 2 volt. The value of upper trip point, to identify the value of UTP, the formula to be used is R1 divided by R plus R2 multiplied by V reference. V reference, it is the voltage that is connected near to your by R1 and R2. So plus R2 divided by R plus R2 into plus V saturation. Here V saturation is going to be plus 12 volt because that is the maximum bias voltage given at pin number 7. The lower trip point can be identified as R1 divided by R1 plus R2 into V reference minus R2 divided by R1 plus R2 into V saturation. V saturation is as usual, that is plus 12 volt. So when you add these two equations, you will be getting the voltages, because here UTP is considered to be 3 volt and LTP is minus 2 volt. So on simplifying, we'll get the value of R1 and R2 as R1 is equal to 3.8 times that of your R2. So here we will be designing the circuit for an UTP 3 volt and LTP 5 volt. So after designing, we'll get the value of R1 as 3.8K. 3.8K we don't have as a standard values, so we are going to select a 3.9K and R2 value is 1K, and the value of your V reference obtained is going to be 0.63 volt. So now when we see procedure, as per the circuit diagram, we need to connect the circuit, and in the signal generator we have to set the frequency to 200 Hz and the amplitude, peak to peak amplitude, to be 10 volt. Now we can obtain the input and output waveform, and this can be viewed in your CRO. After measuring the output waveform, we can draw it on the graph to measure the value of plus V saturation and minus V saturation. This is your expected waveform. It is going to be your input, and UTP, that will be at 3 volt. At V in is equal to 3 volt, there will be a drop, that is from plus saturation to minus saturation it takes place. Again at LTP, that is minus 2 volt, there will be a rise in the voltage from minus V saturation to plus V saturation. So this transfer characteristics or hysteresis loop you can see in when you are keeping the CRO in XY mode of operation. Now we are going to see the practical demonstration video.
Circuit diagram of Schmitt trigger. Here I have connected the circuit. I given the input sine waveform at pin number 2. Here the input is given at the pin number 2. So it is an inverting Schmitt trigger amplifier, and plus VCC given to pin number 7 and minus VE given to pin number 4. Okay. And here at the junction of R1 and R2 is nothing but your upper trigger point and lower trigger point that will be given to the pin number 3. Okay. So every time the input will be compared with your trigger point, upper trigger point and lower trigger point. So according to that you will get the output. So now this is the input waveform I have set. So the input waveform is peak to peak 2 1 plus 1 2 into 2 4 volts. Okay, input is 4 volts. That is peak to peak is 4 volts. And now I want to show the output. So for that I am pressing the channel 2. This is nothing but my output. So here every time the input will be compared with your upper trigger point. This is output. So now I will show the upper trigger point and lower trigger point, which is we are getting at pin number 3. Okay, that is pin number 3 is nothing but your junction of your R1 and R2. Now this is the upper trigger point and lower trigger point. You see here, this is your sine waveform. Okay, you will get the inverted square waveform. Okay, this is nothing but your upper trigger point and lower trigger point at pin number 3, where we are getting this voltage means at the junction of R1 and R2 will be taken and it is connected to pin number 3. Okay, whenever your input is greater than this upper trigger point, then it will be switch over from previous state to next state. See, for example, you see here it is inverting, no. So here when the trigger point is, when the input is greater than the trigger point, here for the this is your negative cycle, this is your positive cycle. You see your trigger point will be your input will be greater than your trigger point at this point. So your the previous state will be changes to the next state. Okay, every time the input will be compared with the previous state and the output will be changes from previous state to next state. This is about your Schmitt trigger.
So after conducting the experiment, we can draw the Schmitt trigger output waveform by measuring your upper trigger point and the lower trigger point, and thus the op-amp as Schmitt trigger is designed and tested for various hysteresis and it was found correct. Thank you, students.